let's continue talking about this conditional probability and mutually exclusive and independent issues. Okay, so here's another problem. So the following data was collected from Mr. Rexinger's high school statistics class. So again, you either wear jeans or you don't wear jeans. You either have long hair or you don't have long hair. So he plays a game with his students. He randomly chooses a mystery student from his class roster. If the student guesses the hair length of the mystery student correctly, the player gets an early lunch pass. So Madeline is the next player to have the greatest chance of winning an early lunch pass should she guess the student with long hair. All right, so basically what we're trying to figure out in A is what's the probability of the student with long hair. Ooh, can't really read that. Let's rewrite that. Hair. Okay, so how many students are altogether in Mr. Rexler's class? So if we add up 7 and 13, we get 20, and then 27 plus 5, so there should be 32 students. And of the students that have long hair, we have 14. We have 14. I'm going to find it with not long hair, so not long. So I know already there are 32 students. So the students that don't have long hair is 18. So even though I don't need a calculator to show you this, but if I take 14 divided by 32, and then I got to take 18 divided by 32. So one is a 56% chance, and one's about a 43 and a 3/4. So it really does make sense that I'm going to choose the not long hair. So to have the greatest chance, should she guess the student with long hair, I'm going to say no. Choose that guy instead. Not long. It has a higher probability or higher percentage of getting it right. Correct. Because there's more people with the not long hair. Okay. So now let's look at part B. So he tells Madeline, right, that the mystery student is wearing jeans. So now all of a sudden he's given her a conditional probability, right? So part B. So would you advise Madeline to change her guess? So would she change her guess? We've already told her to change her guess to not long hair, right? So again. So let's figure out what's the probability of not long given that she's wearing jeans now. All right, so given that she's wearing jeans, so all of the jeans would be 7 plus 5, so that would be 12, and not long hair would be 5 out of 12. So that's what we told her to guess, but now I'm going to do the long hair again given jeans. Again, there's 12 people, and then there's 7. So which one has the bigger of the chance? I'm going to go with this guy right here. So would you advise her to change it again? Absolutely. Change it back to long. So guess long hair. Again, we have the bigger, we have a better percentage of getting it right. Okay? Now, something that we have not talked about that you're going to hear in another course is scatter plots and least regression line, and something known as an association. Okay. Right now, we're not going to worry too much about associations. Basically, this is the most important part, which is right here. If two events are independent, they are not associated. So if they're not independent, then they are associated. That's essentially all that we need to know. So find out if they're independent or not, and then we can continue. So looking at part C, I'm going to have a little bit more space. So we want to know if not having long hair and wearing jeans associated, if there's an association. So basically we want to just figure out, are they independent or are they not independent? So we are going to say this. So the probability of not long given jeans is equal to the probability of not long. Now we've already figured out not long given jeans was 5 out of 12, and then the not long altogether was 18 out of 32, all right, which does reduce to 9 out of 16. So let's go ahead and look to see kind of are these equal to each other. So I'm going to say if we already know, so 5 out of 12 gives us a 41%, and 18 out of 32, or 9 out of 16, right, gives you a 56% chance. So are they independent? No. So they're not independent, which means there is some association. That's all that we need to do right now. So basically, can you just tell me that are they independent? Are they not independent? Okay. Mutually exclusive. So let's go ahead and try mutually exclusive. We have to remember, notice that I gave you, it gave you this information for independence, but mutually exclusive means that you're going to say A and B is equal to 0. So for this one, what's the probability that you will not, with long hair and genes? So is this equal to 0? No, it is not, because not having long hair and wearing jeans out of everything is this box right here. So this would be 5 out of 32, and this is for sure not equal to 0. So are these events mutually exclusive? No. And again, this is perfectly fine for an explanation. All right, let's try one more example like this. So at the Digital Technical Institute, here's the following information. You either are a member of the Honor Society or not a member. Seems pretty straightforward. And you're either on academic probation or you're not on academic probation. So we basically want to know, are events associated at this institute? So basically find out, are things independent or not independent? So we'll figure that out right now. And then are there mutually exclusive events here? Okay, so let's first figure out the part A. All right, so again, we have to use probability A given B, and is that going to equal the probability of A? So let's find the probability of academic probation. So on academic probation. So on academic probation, there are 0 plus 40. So there are 40 students out of, so 0 plus 30 is 30, 30, 200, so 240 students. So that's how many are on academic probation. So now I want to do, what is the probability? So that's my A. So now I want to do academic probation given member. Okay, so I know that given a member, there are 30 people that are members. And then what's the academic probation? There are 0 people that are on it. So basically, is 40 out of 240 equal to 0 over 30? No. So basically, A means that they're not independent, aka there is some association. We'll figure out what that is in a later event. Okay. All right, let's try B. Are these events mutually exclusive? So again, we are doing probability of A and B, and we want to know, is this going to equal 0? So probability of on academic probation and a member. So again, it's all out of everything, so 240. So we're looking at that column right there. So this makes sense, right? You probably would not be a member of Honor Society if you were on academic probation. So 0 over 240, so 0 is equal to 0. So yes, they are mutually exclusive. Right? There are no, how many outcomes are in the intersection of these two events? There are none. So there are no outcomes in that intersection. And that's another way that we can look at the mutually exclusive events. Are there any in there? Okay, we'll get some extra practice with some of this more conditional probability in some of the later sections.